Welcome to Chapter 2, the equation of a straight line. This is where things get really powerful, because we're going to learn how to give every straight line its very own identity card, a mathematical name that tells us everything we need to know about it. This name is its equation. The most common and useful form for the equation of a straight line is y equals to mx plus c. Let's break down these crucial components. First, the m. We've just spent a lot of time on it, and you should know it well by now. M represents the gradient. It tells us exactly how steep the line is and whether it's sloping upwards or downwards. If M is large, the line is very steep. If M is small, it's gentle. Next, we have the C. This is a new term, and it represents the I-intercept. The I-intercept is a very special point. It's where the line crosses or intercepts the vertical y-axis. It's essentially the starting point of your line if you're thinking about it from the y-axis perspective. So when you see an equation like y equals to 2x plus 1, you can instantly read its identity card. Its gradient is 2, and it crosses the y-axis at the point where y is 1. Think about our MRT map again, like a giant coordinate plane. Every straight section of a train line, like a stretch of the north-south line between two stations, can be precisely described by one of these equations. This equation acts like a GPS for the train itself, telling it the exact path it needs to follow to get to the next station. It's truly how we give lines their precise mathematical identity and use them to model real-world paths. Let's zoom in a bit on that mysterious c in our equation. Y equals to mx plus c. This is the y-intercept. It's a really important piece of information for drawing and understanding any straight line. So what exactly is a y-intercept? It's simply the special point where a line crosses the vertical y-axis. Imagine the y-axis as the north-south MRT line. The y-intercept is like your initial station on that line. It's your starting point before you decide to go north or south, or east or west. It's where your journey on that line officially begins in relation to the vertical axis. Now for the math bit. In the general equation y equals to mx plus c, the y-intercept is always the point 0, c. This means that at the very moment when the x-coordinate is 0, which is always true for any point on the y-axis, the y-coordinate will be c. Why does this matter so much? The y-intercept tells us precisely where a line begins its journey or crosses the y-axis on the Cartesian plane. It's crucial for plotting lines accurately and understanding their position. For example, if c is a positive number like 5, the line crosses the y-axis above the x-axis. If c is negative, say -2, it crosses below the x-axis. And if c is 0, the line passes right through the origin. It's a key piece of information that helps define the unique identity of each straight line. Okay, this is a super practical skill that you'll use often. Finding the full equation of a straight line when you're only given 2 points on that line. Let's imagine a real-world scenario. There's a straight, covered walkway being planned to connect two HDB blocks in a new estate. Let's say block A is located at coordinates 2, 5 and block B is at 4, 9. Our mission is to find the mathematical equation that describes this perfectly straight walkway. Here's our step-by-step approach to solve this. Step 1. Identify your points. Clearly label them to avoid confusion. So for point A, we have x1 equals to 2 and y1 equals to 5. For point B, we have x2 equals to 4 and y2 equals to 9. Step 2. Apply the gradient formula. Remember, the first thing we need for our equation y equals to mx plus c is m, the gradient, so we use our formula m equals to y2 minus y1, all over x2 minus x1, plugging in our values. We get 9 minus 5, all over 4 minus 2. This simplifies to 4 over 2, which gives us a gradient of 2. So now we know our walkway has a gradient of 2. Step 3. Find the y-intercept c. We now have m, which is 2, and we know our equation is y equals to 2x plus c. To find c, we can use either point A or point B and substitute its x and y values into this partial equation. Let's choose point A, 2, 5 for simplicity, so we substitute 5 for y and 2 for x. 5 equals to 2 multiplied by 2 plus c. This simplifies to 5 equals to 4 plus c. To isolate c, we subtract 4 from both sides, which gives us c equals to 1. Step 4. Write the complete equation. Now that we have both our gradient m, which is 2, and our y-intercept c, which is 1, we can write the full equation of the line. It is y equals to 2x plus 1. And just like that, you've mathematically described the precise path of that HDB walkway. This method is incredibly useful for engineers and designers who need to define exact lines in their plans. Let's move on to an important relationship between lines, parallel lines. Think about some common sights in Singapore, like the beautifully planned roads in new estates such as Tengah, or perhaps the dedicated cycling paths that run alongside each other for miles at East Coast Park. What's a key characteristic of these paths? They run perfectly alongside each other, maintaining a consistent distance, and no matter how far they extend into the distance, they never, ever meet. That's the essence of parallel lines. In the world of coordinate geometry, this visual characteristic has a very simple and powerful mathematical meaning. Parallel lines have the exact same gradient. If one road has a certain steepness, any road that runs parallel to it must have precisely the same steepness. For instance, if a line has a gradient of 3, any line that is parallel to it will also have a gradient of 3. They are going in the exact same direction and rising or falling at the exact same rate. It's interesting to note that sometimes, when you look at real-life roads or paths from a ground-level perspective, they might appear to converge in the distance due to how our brains interpret a 3D world. This is a common optical illusion. However, if you were to view them from a drone camera, with a perfectly top-down holistic view, you would clearly see that they are indeed parallel. It just highlights how math helps us understand true relationships beyond what our eyes sometimes perceive. So the key takeaway here is simple and crucial. Whenever you hear parallel lines, immediately think same gradient. Now let's explore the opposite of parallel lines, perpendicular lines. These lines don't run alongside each other. Instead, they create a perfect, distinct intersection. Think about how major roads intersect in our city, like the bustling junction of Bras Road and North Bridge Road. These roads are often designed to meet at a precise 90-degree angle, forming what we call a right angle. This type of intersection is critical for managing traffic flow efficiently and safely. In coordinate geometry, this right-angled intersection has a very special and consistent mathematical property. The product of their gradients is always -1. What exactly does that mean? If you have two straight lines that are perpendicular to each other, let's say the gradient of the first line is represented by m1, and the gradient of the second perpendicular line is represented by m2. Then, if you multiply their gradients together, m1 multiplied by m2 will always equal to -1. Let's try a quick example. If one line has a gradient of 3, then the line perpendicular to it would have a gradient of -1/3. Notice how the sign changes and the fraction is flipped or inverted. They are like perfect opposites in terms of their steepness and direction. This property is incredibly important in many fields, from architecture and construction where it's used to ensure walls meet at perfect right angles, to engineering where precise perpendicular alignments are essential for structural integrity. It's a key concept that helps ensure things are perfectly square and properly aligned. Alright, time for our next quiz. This time we're focusing on line equations, bringing together everything we've learned about gradients and y-intercepts to define entire lines. We've got another set of easy, medium, and hard questions for you. Let's begin with the easy question. The equation for a straight bus lane along the PIE is given by y equals to 2x minus 7. Based on this equation, what is its gradient and its y-intercept? This one should be a quick read. You can pause the video to think about it. Moving on to the medium question. Imagine a straight scenic path connecting two famous landmarks. One end is at the Singapore Flyer, located at the coordinates 1, 3, and the other end is at the entrance to the Helix Bridge at 4, 9. What is the equation of this scenic path? Remember the steps we learned to find an equation from 2 points. You can pause the video to think about it. And for our hard challenge, a main road has the equation 4y minus 2x equals to 8. Now, a new smaller road is being built, and it's going to be perpendicular to this main road. This new road passes through a brand new bus stop located at the coordinates 4, 5. Your task is to find the equation of this new road. This requires multiple steps, rearranging an equation, finding a perpendicular gradient, and then forming the new equation. You can pause the video to think about it. Take your time, use the formulas we've learned, and remember the relationships between parallel and perpendicular lines. You're doing great. Good luck. Alright, let's see how you fared on our line equation quiz. Time to go through the answers and clarify any doubts. For the easy question, the equation was y equals to 2x minus 7. This is already in the y equals to mx plus c form. By direct comparison, the gradient m is 2 and the y-intercept c is negative 7. So the correct answer is C. Gradient equals to 2, y-intercept equals to negative 7. Simple as that. For the medium question, connecting the Singapore Flyer 13 to the Helix Bridge 49. Step 1. Find the gradient. y2 minus y1 over x2 minus x1 gives us 9 minus 3 all over 4 minus 1. That's 6 over 3. So the gradient m is 2. Step 2. Find the y-intercept c. Use one of the points, let's say 1, 3, and our gradient m equals to 2 and y equals to mx plus c. So 3 equals to 2 multiplied by 1 plus c. This simplifies to 3 equals to 2 plus c. Subtract 2 from both sides, and c equals to 1. Step 3. Write the equation, with m equals to 2 and c equals to 1. The equation is y equals to 2x plus 1, so the correct answer is B. Y equals to 2x plus 1. Well done if you got all those steps right. And finally, for the hard question about the main road and the new perpendicular road, Step 1. Find the gradient of the main road L1. The equation is 4y minus 2x equals to 8. To get it into y equals to mx plus c form, first add 2x to both sides, 4y equals to 2x plus 8. Then divide everything by 4, y equals to 2 over 4x plus 8 over 4, which simplifies to y equals to 1 over 2x plus 2. So the gradient of the main road is 1 over 2. Step 2. Find the gradient of the new road L2. This new road is perpendicular to the main road. Remember, the product of perpendicular gradients is negative 1. So m2 multiplied by 1 over 2 equals to negative 1. This means m2 equals to negative 1 divided by 1 over 2, which is negative 2. Step 3. Find the y-intercept c for the new road L2. We use its gradient m equals to negative 2 and the point it passes through 4, 5. Substitute into y equals to mx plus c. 5 equals to negative 2 multiplied by 4. Plus c. This is 5 equals to negative 8 plus c. Add 8 to both sides, and c equals to 13. Step 4. Write the equation for the new road L2, with m equals to negative 2 and c equals to 13. The equation is y equals to negative 2x plus 13. Therefore, the correct answer is A. Y equals to negative 2x plus 13. If you conquered this problem, you're absolutely mastering these concepts. Give yourselves a huge round of applause for your efforts in this quiz. You're making fantastic progress.